This is not being recorded, is it? Oh, wait.
Ach, was. Welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
I'm Dan Maloney, staff writer for Hackaday.com and community engineer at Hackaday.io.
This is episode 166. Today we'll talk about engraving with the sun, explosive welding, juggling chainsaws, and torturing Wago connectors. This week we've got tons of Hackaday news in the news, so I'll start off. The Sci-Fi Contest ended on Monday, and the winners were announced just today, which is for you listening out there, just yesterday morning. That was a fun one. I got to go through all of our judges' sheets and collate them all together and figure out the honorable mentions and etc. And this was another one where we just got so many awesome projects that when you only have 3 prizes to give out, it seems really, really dumb.
Sometimes some of the contests don't really, click with people, but this one really did. And they really came out in droves with some great stuff, funny, lighthearted stuff, serious stuff. The fandom stuff really shows through. The devotion to detail really shows through.
Yeah, well, I realized that we hadn't done a sci-fi contest for something like 5 years now. So, part of the problem here is there's just a lot of pent-up sci-fi creativity over the last 5 years. 5 years, people. Everybody's got stuff, and they just want to show it off. And I thought that was absolutely fantastic. Starting off the contest, we made up all these kind of honorable mention categories that we thought would kind of inspire people to do interesting hacks. And one of them was kind of this idea that, I was thinking of Blade Runner, and that happened in 2019. And here it is 2022, right? Blade Runner is so 2000 late. And we live in the future. And so I wrote that one up, and so many people put together, I don't think because of my category, but I got lucky with that. I think so many people had futuristic sci-fi inspired devices, but they actually made them. They were actual made physical normal things. And that worked out really, really well. I thought that was kind of fun. Oh, and of course the winners, I have to say, I got lost in how many of the projects I really, really liked here, but the ones that our judges ended up picking to win include Ruben Fixit's Star Trek Shuttle console, which was basically an escape room puzzle thing that he made for his brother for Christmas, but it is just Star Trek themed to the nth degree and just absolutely beautifully done. I think the other reason our judges loved this is because it was so well documented, and a lot of parts are 3D printed, and he uploaded the models. So, if you need funny mimetic crystals or something for whatever, you've got the STL files for that. Rudy Aramayo's ROB is a gigantic robot. It's a 140-pound metal robot, actual tracked robot that he takes around to sci-fi conventions to help convince people that, science reality is also important. So that kind of fit in with that theme, but also it's just a really over-the-top professional robot build. I thought that was really cool. And last up, a kind of proppy sci-fi build, Zap Wizard's functional Razor Crest control lever. And this one, part of the fun is in seeing his building video and how he made it. It's got this Mandalorian spaceship brushed metal aesthetic. And some of the parts have that because they are made of brushed stainless steel, and other parts are actually 3D printed and covered with aluminum foil that then he kind of electrochemically etches a little bit, and he paints black stuff on it and, ages it basically. But it's really just regular old aluminum tape over the top of 3D prints, carefully applied and trimmed around the edges, and then stained and aged and propified a little bit. I don't know what the right word is. Anyway, and greebled, yeah. The effect, though, is that he's got stainless for weight on the desk, and it actually feels like stainless steel. And then he's got 3D prints covered with this tarnished aluminum for some of the other parts, but it all melds together. He has a 40-minute long making of video, and it's full of a lot of details like that. Besides being a lovely and functional device because you can play video games with it, it also is a fantastic tutorial in how you do some of these tricks yourself.
Yeah, there's a lot of good stuff in here, and I don't know exactly where Curious Mark's entry ended up in the runnings, but
Dude.
that mouse droid, it actually brought me back because it was like I was in 8th grade and the science fair project was coming up. You had to pick your project, and I was gonna pull out all the stops. I was gonna build a robot. Now, and this was like when building a robot wasn't like throwing Arduinos and stuff around. This was you had to go, mail order catalog stuff for, servos and stuff like that. I was convinced I was going to make a robot. And one of the girls in the class, well, what's it going to look like, this robot of yours? And I was like, well, yeah, you remember, did you see Star Wars, that little mouse thing that kind of came up and got scared by Chewbacca? She's like,
awesome.
That's it? Because she was thinking more C-3PO than mouse.
Exactly.
Droid. So it was a little disappointing. That was going to be the reaction of the class if I didn't walk in with C-3PO, and I walked in with this thing instead. So I never built it.
If you walked in with that, it would have been like a tremendous feat, though. So like
it would have been, and they would have been like, "That's it."
Oh man. Yeah, Curious Mark had 2 entries. He had the mouse droid and an old R2D2 model of his, which is just fantastic.
The detail on that.
Dude. And both of those got honorable mention in the Star category, which Star anything, Star Wars or Star Trek qualified for that one.
Star asterisk.
Yeah, it was Star asterisk, but then it turned into Star somehow. Yeah, anyway, his were both there, and I think he and Kenneth Zaborni's chopper droid showed Team Star Trek what's up, and Team Star Wars, hands down, won the contest based on those random droids, I would say.
Yeah, I'd say so.
Anyway, it's really fun. I think we must have featured like 15 projects in this post, and there's lots of pictures, and there's a lot more for you to see. I think there are 70 entries about, so you should go look through all of them. We kind of cherry picked, but there's a lot more to see too. So go spend an afternoon, click through these projects, and see what kind of crazy stuff people are up to.
Yeah, it just goes to show when you're having fun, sometimes it really stimulates the process.
Oh, and speaking of prizes, the Hackaday prize is coming to a close on the first round. This is planet-friendly power, so it's like solar, but then all sorts of other alternative power supplies, and storing them, making efficient use of them. The news section here is that the deadline for getting your planet-friendly powered projects into the Hackaday prize is Sunday. So head yourself on over to Hackaday.io and get your project registered now. You've got a couple days. Be aware, though, it's Sunday and not Monday. We usually throw the deadline for these projects on a Monday. This one is, unfortunately, on a Sunday, so you got to get her done on Saturday.
Yeah, so my bit of news for today, news from Mars, as it often is with me, because that's where all the interesting stuff's going on. I think Scott Manley did it best. He put out a short video just a little while ago with the provocative yet completely accurate title of Alien Spacecraft Discovers Flying Saucer on Mars. You can't fight that. It's completely correct, because was Ingenuity is an alien spacecraft that's on Mars.
On Mars, right.
And it discovered a saucer-shaped object that previously was flying, the back shell that got it and Perseverance onto the surface. That was jettisoned while it was up in the final descent stages there, went off and landed, I forget exactly how far away from the landing zone, it finally crashed down to the surface, looking quite the worse for wear from Ingenuity's cameras, and you can see the parachute stretched out behind it. Absolutely beautiful, stunning that they were able to do that. And I'm not going to say that they took my suggestion to do that, but I did write that last week, I think, in the links column. I said, hey, as long as you're there with the helicopter, you might want to take a look at that stuff. And they did. So I guess we get results here at Hackaday.
That's right. Hackaday asks, NASA answers.
Yeah. And I am working on a more in-depth article on the first, 360 something sols of the first year basically on Mars for Ingenuity and all that it's accomplished so far and above what it was intended to do. It's 5 flights that it was going to do. It's currently up to 25, 26, something like that. Absolutely amazing that it's done as well as it has and it's still clicking.
This is a journey into sound.
What's that sound?
What's that sound?
And that brings us to What's That Sound? This week is a sound challenge week, so your mission, should you choose to accept it, is to listen to the following sound. If you know what it is, head on over to hackaday.com/podcast, fill out the form you'll find there, and let us know what it is. What do you think?
That would either be or sounds more like
Yoicks. I'm going to have to bleep all those out. Damn, Dan. Very impressive. Very impressive.
old school geek.
Yeah, right? Oh, man.
When it's all you had to hack, you hacked it.
Ouch. I'm going to have to bleep out everything you say here. Fantastic. Well, congratulations, Dan Maloney. You may also recognize these clicky sounds. I tried to pick the most characteristic ones, and apparently it worked. Wow. I'm impressed. I thought this was going to stump you. Y'all out there, if you know what the answer is, head on over to Hackaday, fill out the form, and next week we will reveal who has the right answer, roll some dice, and figure out who gets the Hackaday Prize t-shirt. All right, well, that brings us to the hacks. I'd like to start off with a hack from Cranktown City's YouTube channel. And in this episode, Lucas is making a CNC engraver, but it's unlike one you've probably ever seen before. Normally, when you think of these like laser CNC engravers, you think of something that's got a couple watts and, you know, shines a laser on some wood and maybe can burn your patterns into it. He's like, well, what's the expensive part? It's the laser. I'm going to substitute that for sun power and a lens. And so this thing is basically just the old magnifying glass, like focusing the sun down on a piece of wood and burning it, except it's that driven by a 2-axis CNC machine. Except there's one extra wrinkle that actually I didn't think about until watching this video, which I really appreciated. And that is, if your sun lens burning process is going to take you a while, you actually have to follow the sun. And so he's got not just the 2 axes that you need to engrave the picture, he's also got an extra sun tracking system set on this thing. So the whole machine moves around and then it draws it as it goes. And that is what's really cool about it. It uses this kind of absolutely classic square quadrant sun tracker that he makes. And that is basically you take, I don't know, what is that shape? It's 2 plates, 2 planes that intersect each other at a 90-degree angle.
Yeah, I had trouble describing that when I wrote the article. I was going for cruciform or something like that, but
Thanks.
But yeah, they're orthogonal to each other. They're just 2 pieces of metal.
2 sheets of metal 90 degrees to each other, and then you put a photo sensor in each of the 4 of those, and that way you can tell whether, if you align those actually with the motors that move the thing around, you can do a 1-to-1 correspondence with this cell's brighter than this cell means turn that motor, and this cell's brighter than that cell turn the other motor. And you can, it makes for an extremely simple kind of no logic solar tracking device. Of course, if your axes aren't all square, but you've got an Arduino in the middle, you can figure out the math yourself. But it's a really, really cool idea. And I mean, is this a practical thing? I'm not so sure. It certainly uses a lot less electricity than wasting all that power on a laser when the sun's shining outside.
Lucas kind of cracks me up. He presents as a bit rough around the edges, but he is sharp. He's got a lot that's going on in these videos. And just because he did this with a magnifying glass doesn't mean that he doesn't have, access to lasers. In fact, he even made his own laser, not from a tube that he bought. He built the tube for a CO2 laser and actually got it to work. It didn't work so great, but he actually got, a little bit of engraving action out of it, which I thought was pretty fantastic. The other thing that got me about this is I can totally picture him as a boy with a magnifying glass, as I did, doing basically the same thing, just kind of trucking along on a piece of wood or something like that, or your brother's foot, is in my case, and trying to engrave something like that. And I can also remember, having that focus issue too. Like I'd notice, oh, look, the projected point is a little bit oval. Oh, well, I need to move the magnifying glass a little bit because the sun has moved since the last bug I burned or whatever. I can also remember defocusing it a little bit and actually seeing sunspots for the first time.
Yeah.
Which blew my mind that you were able to do that with just a magnifying glass.
What is a telescope if not
exactly
a couple magnifying glasses strapped together or a magnifying glass shaped reflector?
Yeah, now just kids, don't try this at home. Don't point that magnifying glass directly at it and then shine it in your eye. You're going to have a bad day if you do that. But
this machine is kind of rough and ready. From the design, of course, it's a little bit absurd, right? Like it's a beautiful 2D machine, and then it's mounted on another 2D machine to make it track the sun. So it's kind of, I don't know what, it's in principle crazy, but I think that's part of the beauty of it.
Yeah, he's certainly not afraid to throw metal at a problem.
Yeah, that's the truth. Yeah, I need to learn to weld. That's my biggest weak point at this point. I got to work on that.
And once you do, you don't get good fast. It takes a long time.
Anyway, this project reminded me of a project from a long time ago. It turns out, my God, 2011, selective solar sintering with sand. This was a kind of an art project / a demo project that someone did with a gigantic Fresnel lens, but it's basically the same thing. Get enough solar power in one spot that you can melt sand, and then you mount this thing on a gantry so you can move it around and point it around. It's not a high resolution device, it's a rough and ready device, but the fact that it can work at all is pretty amazing. The fact that you can make ceramics without a kiln with just a gigantic Fresnel lens, and then you can steer it well enough to actually make complex shapes out, is really neat. And that this is from 2011 and we haven't seen more of this, until a goofy wood burning project is a little bit of a shame as far as I'm concerned. I mean, what is a laser? It's a lot of light in a very small space. But if you've got the sun out there that's like a bazillion times brighter, all you need is a lens. And then you've got that much power or more at the focus. So that's kind of a neat idea. And I really like it. And I wonder what other crazy, burning 3D printing hacks you could do with solar power as the prime force.
Well, my first pick is testing 7 Wago-like wire connectors for Science and Fire by Maya Posh. This is based on a Great Scott video, and I'm just going to say for the record, Americans and Europeans, we got a lot of problems with each other. We got a lot of friction from time to time. I don't buy into a lot of it. You guys do your thing. We'll do our thing. Let's just, everybody's friends. It's okay. We can be different. I will say, though, I greatly covet all things residential electrical in Europe. Your service panels, I love. They're just, they've got DIN rails in them. How could they be any better? I would love that to come over here. But what I really, really enjoy, or what I really want to come here, is these lever clamp terminal blocks, of which Wago is an example. I love those things. Using a wire nut to put together a circuit here. I've actually gotten away from it and gone with some push connectors, which I don't really like them that much, especially with stranded wire, but they're good for solid wire. Wagos are good both ways, stranded, solid, works great. They're clean, they're neat, they're easy. They are a little on the expensive side. So what Great Scott did here, who came up with this video, was to go through your favorite online buying place and buy up a whole bunch of Wago and Wago-like connectors and put them to the test. Surprise, surprise, it basically boils down to you get what you pay for. There's only so much you can expect from something that's mass produced. the price point really reflects that the manufacturing controls that have to go into that little device, which must be stressed is going to go into a wall and have either 120 or 240 volts flowing through it, and has the potential for burning your house down if it's improperly used or improperly manufactured. Surprise, surprise, you're really going to have to put out some money to get a good product there. The cheap ones are cheap. End of story. I will say, though, that wire nuts are terrible. I mean, I use them all the time, but they're terrible. Wiring up a circuit with wire nuts feels a lot like watching a plumber pour a molten lead joint in cast iron, in this day and age where, a regular plumber was probably, using PEX and cutting the little plastic tubes and doing crimp connectors and all that stuff. Bing, bang, boom. You've got the whole process all done. But plumbing used to be actually throwing chunks of lead into a ladle and heating them up with a torch, pouring that in, and the clay dam and all that stuff. That's what wire nuts feel like. It's like watching an old trade art that should be disappearing. But I will say that getting wire nuts right from a manufacturing standpoint is probably a lot easier than getting lever type terminals right. Whether that means that, you're more likely to get a defective product or a substandard product if you are buying, downscale on the price range with a lever terminal than you are with a wire nut. Maybe not. I guess that's pretty much what Great Scott found here. Still, the convenience and the tiny incremental expense for the convenience of a good solid connection that actually feels like it's not going to fall apart is probably worth it to me.
I'm glad you knew about these because so I moved to Germany, 10 years ago now, and I'd never seen these before I got here, right? And then you see these everywhere here, and they're really neat connectors. This is one of those places where Europeans scoff at Americans with their wire nuts, and I do see why a little bit. Just from a pure engineering standpoint, this thing clamps the wires together and it makes the contact with this lever flips down, and it actually has a spring that then pushes into the metal. Whereas when you do a wire nut, you cram it down as tight as you can, but then except for the nut stretching, there's no extra compressive springy force holding it together after that. And so the chances of them kind of wiggling loose over time, especially if there's any vibration, is a lot higher. And that's one of those places where this is just a better technological solution. But it's such a German technological solution. And because I live here, and if I watch YouTube, every once in a while I get ads from them. And if you watch them, they're absolutely hilarious. It's a 6-minute long infomercial ad with these two serious engineers talking about their wire connectors. And this one's better for stranded wire. This one's better for this connection. This one's better for that connection. There's serious thought going into this. And, like you say, I guess if it's going to burn your house down, maybe it's worth putting that serious thought in. So I do see that too. I grew up with wire nuts though, so I'm not totally. I grew up with wire nuts, but I live in the land of the Wago Klemme, the Wago clips. I don't know which one's better. I won't pick sides. I can't betray the motherland either. But
I can betray it a little bit because I'm working on a solar project and I needed to connect. I need to make a connection between my panels and the combiner box, and they're 10 gauge wires. I don't know what that is in square millimeters, but it's a lot. It's a big wire, and they're solar, MC4 wire, which is very, very fine conductors, lots and lots of fine conductors, the kind of thing that it would be nearly impossible to put into a wire nut. And I could get number 10, something that could do 2 number 10 wires in a single wire nut, but I didn't want to. So I just went out and I ordered a bunch of Wagos. I got 5 and they cost $10, but $2 a piece for easy. It was a no-brainer to me.
if you look at the video thumbnail on this one, though, just so's you know, the picture is of a charred, knockoff Wago connector. I'm going to say Wago or Vago. I don't know which. Again, betraying the motherland. But, he's got his picture of a burnt one of these, and he tested them with a torch. This did not burn out from natural causes. didn't
That's
run
a good
enough
point.
juice through it that the thing spontaneously combusted. The question here was, if they do get on the wrong side of a heat problem, will they melt? How will they fail? And so that was the test here. It was not that he was able to run enough juice through it. On the other hand, of course, you could if the connection there is high enough resistance that it actually generates significant losses and you're running something heavy like a solar installation or whatever through it. Of course, that could heat it up. So, it's not an unrealistic concern. It's just that he didn't test it by running kilowatts through these little things on his bench.
Yeah, and I do remember writing up an article on someone who did that, actually. Did a test on these kind of terminals. Also did a head-to-head with
Yikes.
traditional wire nuts. I can't find it right now. If I can find it, I'll put it in the show notes. It's possible to get them to combust quite readily. The other thing this one reminded me of was the time I got somewhat taken to task for showing off a print-in-place version of Wago-like connectors. I thought it was pretty clever, but the safety sallies in the comments were, and justifiably so. Again, if you're using this for household current, you're probably asking for trouble. But these little wire nuts that this person was making were basically intended for quick, low voltage connections. And I thought the clever bit was that they were, first of all, print in place, and second of all, they were just using a piece of copper wire as a bus bar against which these levers press the conductors. But I still got a little bit beat up in the comments for calling them Wago-like connectors.
I actually printed some of these up after reading this and have tried them out, and they're really fun. I don't know if it was the tolerance on my 3D printer, but there were a few where I latched them and I could just never get them to unlatch again. Like, you have to just put so much force into it. Maybe I'm printing a little fat or something, but it's a really, really cool design, and I absolutely agree. So definitely worth looking at. It doesn't meet codes, but for playing around, it looks like a lot of fun.
Is it really possible for us to talk about Wago connectors for 15 minutes? Yes, it is.
My next hack comes from Michael Zalewski. Omnibot shows off over a decade of CNC prowess, and this is, first of all, about a really cool robot design of his. It's a 4-wheeled platform, and each of the 4 wheels can, well, of course, they can turn like normal wheels do, but then they can also rotate so that they all go left or right. They're all steerable wheels, except they're all steerable in pairs in a really interesting and geared fashion that lets them not only steer in a turning direction on all 4, but you can turn them out sideways. So the thing can actually go, like if you imagine it's driving forward, the wheels can actually all turn out so far that it can drive then 90 degrees to the direction it was previously in, or kind of any of these other simultaneously skewy directions just by moving the wheels. It's a really sweet mechanism. But that's not the point either. The point is, if you don't know Michael Zalewski's name, he is the author of a longtime favorite of mine, The Guerrilla Guide to CNC and Resin Casting. I learned about this first a million years ago, 11.5 years ago, on Hackaday back in 2010. In his original version and also in the updated version, he is basically advocating for using a small CNC machine to make silicone molds to then cast polyurethane in as an alternative to 3D printing, basically. So for all the kinds of things you would make small robot parts with, he can do it finer and probably stronger by using a casting and polyurethane system. One thing that matters a heck of a lot is getting the right material to make your first part molds out of. And he uses something called Ren Shape, which is a specially made plastic that's super easy to mill with the CNC mill, but it also holds detail really well, and it's nice and homogeneous, so it cuts easily. It's really like the right thing for making molds out of, and it puts not much stress on the CNC mill, so it can be super accurate and can make super fine details in it. And then he pours a silicone mold into that. So this makes kind of a positive. He then pours a silicone over this to make a negative mold. And then he pours polyurethane back into that that takes then the shape that would have been made by the Wren shape. And the advantage here is that he can do the hard machining on a very easy to work material, and then through this like 2-part molding step, get it into something a lot harder, or either harder or stronger or impact resistant, like you can make out of polyurethane without having to stress the CNC machine.
Yeah, I like the sort of the secret sauce aspect of this, and finding out about these methods and materials that, I mean, you just, fortunately, unfortunately, I guess is the right way to put it. It's easy to just 3D print it, whether it's FDM or a resin printer or whatever. Okay, we're just going to do that. It does pay to think, well, is that really the best way to do this? Is there maybe another way? And, when you know that these materials are available, and when you know that these methods work once you've practiced them a little bit, it's still a lot harder than just, plugging a thumb drive into a printer and walking away. But the effort that you've gone to get to the point where you have the skills that you can make a mold quickly and do some quick resin casting is well worth the investment in time, I think. And, were I to build out my shop, that would be the way I would go. Small CNC router, ability to cast different materials with the occasional, I'm just going to throw it at a 3D printer because you just need something quick and dirty. I think that's probably a really good mix of technologies to have in a shop.
The trade-off, I think, is a couple more steps worth of complexity. Like, first you have to learn about CAD and CAM stuff to get the CNC router working. And that's actually kind of a skill and an interesting thing to learn all on its own. And then you have to learn about mold making. And I think in terms of expense, the one thing that he has there is a vacuum chamber, because he's super careful about degassing all of these 2-part silicones and 2-part polyurethanes that you end up mixing together, right? And so you get air bubbles in it, and that needs to go out if you want super fine detail. So he does need a vacuum chamber, but then after that, it's not all that bad. The rest is just kind of, wear gloves and measure your parts out appropriately. But like you said, there's a lot of secret sauce, and a lot of that secret sauce is in just kind of knowing what the parts are, knowing what the ingredients are, knowing what all of the things you can do are. And that's what's fantastic about his guide.
Okay, so my next one is Machine Learning Helps You Get in Shape While Working a Desk Job. This one's by Victor Sonk, who laments the fact that he's spent a lot of time at the desk in his chair. Humans aren't really made for that kind of thing, but it's awfully hard to get yourself motivated, especially when you get in the zone. And, we all know that we should get up and exercise. Changing from one slump to another is not necessarily, that doesn't necessarily count. I'm actually pretty good about it because I've just got my little shack out here. I don't have a bathroom, so when nature calls, I've got to get up and head into the house. So, I'm walking back and forth to the house quite a bit. He's taken things to a little bit more extremes. He wants to kind of over-engineer this and build a system that will lock his machine completely, prevent him from doing any more work, and not unlock it until he does 5 push-ups. So he built a machine vision system that basically watches him do 5 push-ups. If he hasn't done the 5 push-ups, his machine doesn't get unlocked. I think it's delightfully over-engineered. You could manage this a lot more easily with maybe like a Pomodoro style kind of thing, one of the timer things, and any number of tools that already exist to just remind you to get up and take a break, do something else. But hey, he knows himself. He knows he's not going to do that. He knows he's just going to click on that. Yeah, I'll do that again next 15 minutes. It kind of reminds me of those alarm clocks that for the really, really hard to wake that require you to do something like solve a puzzle or get up and walk across the room. That was a hack that I used to use when I had to wake up and it was particularly early. I would just have an extra alarm clock across the room, and just getting up was kind of enough to wake me up and that I wouldn't go back to sleep. But apparently he knows himself well enough to know that no, that's not going to work. I need an enforcer. he really threw the kitchen sink at it as far as hardware goes. He got a 4K camera and built-in machine learning in this processor that he's using. It's, like I said, delightfully over-engineered, and I applaud his self-awareness. And man's got to know his limitations, as Dirty Harry said, and he knows that he's not going to exercise without a machine telling him to do it. So
I think he knows that he wanted to play around with pose identification algorithms and with all the rest of it. I'm not buying this like push-ups angle one bit. I don't even think you need an excuse to play around with pose recognition. Buy the camera, dude. Don't even worry about it. Just have fun with it. Enjoy. No, I think he had a great time with it, and it makes for an absolutely hilarious project. My next hack is a twofer of old school analog darkroom hacks. The first one I thought was really sweet is Muth's digital to analog in the darkroom. This is really cool because he's taking kind of the oldest and simplest method of making photographs, and that is making a contact print. And the idea there is, back in the day, you would have a photographic negative. Instead of projecting it through a lens and an enlarger onto a piece of photographic paper, you'd actually just sandwich them together so that the photo paper is in direct contact with the negative, and then you develop that. The advantage of a contact print is if you have a big negative, it makes a big print and it has fantastic resolution in it. So his gimmick here is he wants to do a digital contact print. And so he manages to get his hands on a black and white 4K LCD screen. And he puts this then down on old school analog photo paper, exposes it, develops it, and he gets an actual print out of it. The coolest part about this project, for me anyway, was the way he goes about doing the exposure. And in the old days, if you just had a negative, you'd put it on there and you'd control how much time the light's on or off, and that would control, how dark or light the image is on the paper. Here, he's got an LCD screen in the middle, so he can change the image while it's exposing. And he can control the exposure not just by how much time the light's on and off, but also by changing the pixels on the LCD as it exposes. And so he works out this whole system where he does essentially like a digital test strip where he figures out how much exposure makes the resulting print this dark or this dark or this dark. Then he writes a program that progressively blackens and whitens part of the LCD screen to selectively do this exposure over time. It's a really clever idea, and it lets him get very fine-grained control over how the contrast in the image gets printed out by being able to vary it over time. And it means he's not limited by the intrinsic contrast of the LCD screen, but instead by like what fraction of time a certain pixel is on or off. And so he can really play some interesting games with the exposure there. And I think that his resulting prints, except for the fact that when you get up to it with like a super sharp magnifying glass, you can see the LCD pixels. With the exception of that, they look absolutely beautiful, or at least, how they show up in the LCD pixels that I'm viewing them through. The other photography darkroom hack that I wanted to talk about real quick is simple photo enlarger makes great addition to any darkroom. This is a hack that came out, I think, like one day before the other one. 2 darkroom hacks in a row by Dan K. In this one, he's making an enlarger out of basically a camera lens and a nice LED light source. What struck me about this project is how easy it would be these days to make an enlarger yourself, basically if you have a good lens and if you can get everything aligned right. Because with my old enlarger, the real hard part was taking an incandescent bulb and getting a nice even light source out of it. And of course, if you have an LED, boom, you're sorted. You get a nice diffuse LED light source with some good diffusers on it, and you're done. You're probably staring into a nice diffused LED light source at the moment if you're looking at a computer monitor.
Last one for me, harder drives, impractical, slow, amazing, and incredible. First off, I got to say, hats off to Ryan for taking this one on. I really tried. I watched the video. I was absolutely floored by it. Tom Seven is the OP here. Basically, what he's doing is looking for the worst possible way to store information and making it work for various values of working. The video is hilarious. It's worth it just to watch for the jokes and the cool animations and graphics. Basically, what he starts with is a description of juggling chainsaws, which is amusing in and of itself. How if you could juggle something so high, it didn't necessarily have to be a chainsaw, but if it were a chainsaw, you could have a series of chainsaws that were either on or off, and by the time that chainsaw returned to you, because you're obviously capable of throwing a chainsaw into the stratosphere, the time delay would present a return of that information, which is basically what you're looking for when you're building memory, similar to the early sort of delay line memories and stuff like that need to be refreshed. The refreshing part would be taking that chainsaw that's coming down, that's either on or off, noting its state when it passes you, and then throwing it back up there because it's going to come back in another couple of minutes or whatever it is until it finally comes down. So it was kind of tongue-in-cheek, obviously. He's not proposing that we put chainsaws in orbit to act as memory, but he does move on to radio propagation. So for like high frequency radio waves, propagation, ionospheric skip, we've talked about that kind of stuff before, ham radio stuff. That's how the hams get their long distance communications, by bouncing their signals off of the ionosphere. And he proposes that you could use that same thing, because it takes a finite amount of time for the signal to come back around. You could use that as a way to store information. That was just like sort of a thought exercise, I believe. But where he actually came up with something that was workable, quote unquote workable, was using the entire internet for packet storage. And he's using ping. So the ICM protocol, I guess you would actually say, which will let you send an arbitrary packet of information to an arbitrary IP address somewhere in the world. Again, there's a propagation delay. So you could, in theory, and he does this in practice, you could send out a packet of information that you want, quote unquote, stored, by sending it to a distant computer and having it echo it right back to you, because that's what ICMP does. He made it work. He actually was able to store data in the internet.
Yeah.
Without people's permission, generally. He just sort of scatters these packets out there and keeps track of them as they come back. It's pretty darn cool, if you ask me. He takes that to the next level. He kept kind of upping the game every couple minutes in this video. And it's like every one of these sections could have been a video in its own right, but he just kept kind of piling out things on. Eventually used Tetris as a storage method and built a game of Tetris in a bunch of virtual NES consoles that were scattered around the world. And he made a playable game of Tetris out of this.
This one was mind-blowing because there's some predictability to what block's going to come up next, and it's timing dependent. And so how he would move the blocks down faster or slower could influence what block he would get next. And the whole goal here was then to store his data as either blocks or spaces on a line in a game of Tetris. What?
Yeah, that was the subtlety that kind of blew my mind, is that, that second line up or third line up, whatever it was, that was that's the read head or whatever, I guess it would be. And when that was populated, then he'd call it done. What? And just got weirder from there, because next he's pulling apart buckets of old COVID tests that he got from his employer. They're the kinds with electronics is built into it, because everybody knows you need electronics in a COVID test. But he had a bunch of, what were they, EEPROMs, I guess? The little tiny 8-pin chips. And there were 512 bytes or something like that. That's all they could store, but he managed to harvest all these things out of the icky used COVID tests and made a hard drive out of it. And the funny thing is, for each one of these things, he was able to mount this drive and see it as a drive like any other in his system, like a USB drive or like or anything else, and use it. It was slow, impractical, like Ryan said, but also amazing and incredible. And it was a great journey. I think it was probably a half an hour video or maybe even longer, worth every minute of it, just to have your jaw just drop every couple minutes. Like, did he really do that? Yes, he did.
Every year, Tom Seven puts out these Sigbovic videos. There's one of these, like, literally every year. There was one where he did... Oh, there's some video game hacking ones. There was one where he did a zip file that contained an executable with the source code for the zip file in the executable for the source code with the zip file. I mean, there's some really... You should go back and watch his back catalog if you haven't. I think my favorite part of this one is that he analyzes each of these stupid hard drives that he makes for, like, how much money they cost per stored byte. And, sending out pings actually is pretty cheap unless you count the expense of the internet infrastructure in the world. And, doing the Tetris one was really cheap because it's just virtual machines. If you had to buy all of the COVID tests, over the counter, because they're like $70 each, but they have 512 bytes, it ends up being, expensive. That ends up being kind of the most expensive one at about 13 cents a byte. And then he just throws in as an extra fillip about 35 minutes in there the cost of storing your information in the blockchain, which is 34 cents a byte. It's like twice as bad as the worst hard drive, as the worst information storage method he could come up with, which is using these $70 COVID tests and desoldering the EEPROMs. And if you compare that to how expensive it is to store your data in the blockchain, it's a bargain. It's a bargain.
Yeah, so hats off to Ryan for writing it up. I tried, and, congratulations, you did it. You won that one. And congratulations to Tom Seven for entertaining and enlightening ways to store data.
My first quick hack this week comes from Nick Poole, and it's an entry in the Hackaday prize: glass tube solar thermionic converters. This is a solar power harvesting device that I hadn't heard of and learned about through this experimentation that he's doing. Instead of photovoltaic cells, which convert light into electricity, these get hot and use the heat difference between two sides of it to make electricity. They're a little bit like old vacuum tubes, and so he actually tries to use a standard amplifier tube to get electricity out of, discovers that he can. His next steps are going to be kind of figuring out how to engineer a better thermionic converter. I want to see it happen. Next up, CAD Sketcher. It's parametric CAD for Blender. H. Loris put this out. It's really interesting. A lot of people use Blender as a 3D modeling tool for then making 3D prints. This adds an extra parametric CAD layer / plugin into Blender. So if you're already comfortable with kind of the Blender workflow, or you like it because you like making organic shapes, this can add that easy, I need a hole here that's 14 millimeters away from this other hole there kind of aspect that's important when you're making functional 3D objects. And last up, this one's a Red Bull ad, but I really liked it. Drone filming Chile's urban bike race takes some fancy radio gear. This is the Dutch drone gods doing some outstanding quad flying. They're chasing mountain bikers down an urban mountain bike race course. Because they're going through an urban situation, there's all sorts of buildings in the way, and they have a quad with a radio relay to relay video images back to the people doing the FPV flying. It's an interesting technical setup. I wish they had a little bit more about it, but what do you want for an advertisement? For that, they actually did pretty well. But if you want to see some crazy quad flying, this is a good one to watch.
Okay, my quick picks start with a look at the Nord Stream pipeline, all dressed up and nowhere to flow. Russia's Nord Stream 2 pipeline. Ryan wins the headline contest for this week with that one. But it's a Grady video, Grady from Practical Engineering, which are always a joy because he just explains things in a way that nobody else can in terms of infrastructure and civil engineering. What really hit me about this one is that I never really thought of the implications of having a pipeline underwater. Like when you make it, it's a tube full of air, which will not sink unless you cover it with a whole lot of concrete. Then again, now you've got a big tube at the bottom of the Baltic Sea or the North Sea. And what are we going to do with that? What are the implications of that? Grady's always good at explaining all of these things about technology and infrastructure. My next choice is the Apollo Digital Ranging System is more than meets the eye. This is an abstract of a Ken Sharif blog post. We've been paying attention to the work they've been doing on the Apollo guidance computer. We've seen that before, but they also managed to pick up Carl and Curious Mark and Mike, I think his name is. I can't remember his last name. But anyways, the usual team who tears down Apollo gear for them came upon these radios, and the system that was used for ranging and speed telemetry in the Apollo missions is gone over here in great detail by Ken. It's a lot more complicated than you think it would be, but it's necessarily so, partly because it was 1960s technology, but also partly because it actually turns out to be pretty hard to tell how far away something is in space and how fast it's moving, when you're actually have people in it rather than an inert object. It's a great overview of what the systems were that were in Apollo that were necessary to make this happen, and a lot of fun to look at the details. My last pick is, I'm going to mispronounce it, Janelli's Rods, When Paint Sticks Do Math, by Chris Stecker. This is an interesting video. It's kind of like Napier's Bones, if you're familiar with those. Basically, it's a series of sticks that were used to do a multiplication or division when you have a lot of numbers in one of the factors. Chris does a good job of explaining exactly what's going on. And I think if I watched it through one more time, I would see where the numbers lined up. But basically what happens is you arrange these sticks in a certain number to represent one of the factors in the problem you're trying to solve. And then you read the answer back from right to left or left to right, depending on whether it's multiplication or division. And it gives you the answer. I thought it was pretty amazing. And the important thing here really is Chris's channel is great. He goes over all kinds of old computational tools from adding machines to the little things that took the place of calculators before we had calculators, where you'd put a stylus in and just kind of run a column of numbers up and down. Manual tools like these things, like Janelli's rods, like Napier's Bones. And he's got a really good style and a really good presentation on making mathematic difficult concepts easy to understand.
That brings us to our Can't Miss articles. These are long-form articles written by our fantastic Hackaday writers. This week I picked Explosion Welding Goes Off with a Bang by Lewin Day, and I picked it because this was the thing that I learned this week, is that explosion welding is a thing. The basic idea is exactly what it sounds like. You lay down a strip of dynamite on top of two pieces of metal, one of which is then backed with something, basically immovable. You explode this, and the explosion forces the two pieces of metal together so fast and so hard that they essentially weld. And it makes a particularly interesting weld because you can put metals together that you otherwise wouldn't be able to do with kind of slow heat welding. And there's a bunch of other fun properties. Like, one of the things you do is you leave a little gap at one of the angles. Lewin stole a great image here from an old NASA document that I'm gonna have to talk about in a minute. And it shows, as you slam these together, where they're making contact, it gets so hot so locally that there's a little plasma jet. And this plasma jet then scoots out of the way as it goes, cleaning the surfaces, leaving these two metals welded together, very thin weld, not even a super hot weld, but then super clean because it was just cleaned by this plasma jet that went flying through. Like, this is a crazy way to join two metal plates. And he does say at the end, given the fact that this uses high explosive, this probably isn't the way you're going to weld things in your garage. And that's probably true. But he does dig up this great old NASA tech paper that you should read. And as often is the case, these kind of glimpses behind the scenes are really worth it. This one is called Practical Small-Scale Explosive Seam Welding, as if anything were practical about explosive welding. But it has these marvelous descriptions, including produces metallurgical bonds that are impossible to achieve by other joining processes. The explosive welding process is accomplished by a high-velocity angular collision of metal plates, which effaces oxide films on both surfaces to allow interatomic/electron sharing link-ups through van der Waals forces. So that's the good stuff, right? Like, these metals are joined together as if they have kind of their own intrinsic strength, and no strength is lost in the joint. The several million PSI explosive pressure on top of the flyer plate produces velocities in the plate of several thousand feet per second. On impact, the kinetic energy is converted to skin-deep melts, which are stripped from the surfaces and squeezed out by the closing angle, etc., etc., etc. And then it goes on to talk about how you would want to do this, why you would want to do it. Anyway, this is not something you're doing in your garage, very likely, but it is a really interesting technique that I had never heard about. One of the other high points of this NASA document is that because you don't have to use fire or, any extreme heat, at least, not for a long time, you can perform these explosive welds under hazardous conditions, end quote. Whereas, as if, like, the explosive welding itself isn't a hazardous condition. But I guess the point is you could do it in space, you could do it in the presence of nuclear radiation, toxic atmospheres, in a vacuum, super high heat, super high cold. None of that matters because you're exploding the two pieces of metal together.
So, can't do it in my garage? Challenge accepted.
I recommend against it. Okay. I would never say you couldn't.
Yeah, I think we have a little thing called the ATF here. I think they would probably, and they've got an E at the end of their name too, so they would probably look askance at this. But I think I would bet that this goes back. The technology here has to go back at least as far as the Manhattan Project. This kind of stuff has Manhattan Project written all over it. A major part of what the early part of the Manhattan Project accomplished was learning how to control explosions, because they knew they needed to be able to compress the uranium or plutonium into a critical mass, and they had to go from a safe place to a boom boom place, and they had to do it very quickly and very controlled. So a lot of that early research was not anything to do with the nuclear aspect of it. It was all, how do we get things to explode in a predictable way? And I bet you this kind of comes back around from that, at least partially. The other thing it reminds me of is the exothermic welding techniques that they use for joining railroad tracks together. Basically, it's piling a bunch of thermite onto the joint between two rails and letting it off and having it basically be, turn into lava and weld these two tracks together. It's not quite as explosive as this, but it's still energetic. And these highly energetic processes like this are really interesting to me. Probably more so than they should be.
You'll get on a list, man.
Fire in the hole, baby. The other thing this reminds me of is explosive forming of metal. I've seen these spherical tanks made out of, I guess it's basically flat sheets of metal that's welded together kind of like a globe, so it gores. But then to kind of puff it out to make it an actual sphere, they put a load of explosive in the center of this sphere, and poof, it goes off and ding, now you've got a sphere. All these energetic processes really entertain me much, much more than they should. And I really enjoyed this one.
What's really fun about the NASA thing, again, has to do with the propagation speed of the explosion through the explosive. So you lay out a really long strip and it goes. Rapid operation is one of the pros of using explosive welding.
Yeah, it's rapid.
Yeah. 26,000 feet per second. On initiation of the explosive, the joining process proceeds swiftly. Anyway, I just love it when I learn something crazy and new like this, and I guarantee you I will never explosively weld anything in my life. But I am a happier man for having read a white paper on how I would.
My pick for can't miss article this week is the Honda Takedown: How a Global Brand Failed to Read the Room by Jenny List. I kind of touched on this Honda problem in my links article last week. I had noticed that someone had sent me a tip and said that Honda was taking down or issuing takedown requests for any kind of 3D print model files that included the word Honda in them. It seemed to be only on the printables part of Prusa. So it wasn't Thingiverse and it wasn't any of the other sort of 3D model repositories that we all know and love and frequent. But still, it was kind of concerning that a major brand like Honda was apparently targeting 3D printer aficionados and people who put a lot of work into making models that may or may not have had anything to do with the Honda brand. The distinction between something built for a Honda or something that is Honda, that is a Honda part, is a fine one, but I think it's really important in this case. I think the interesting thing here is that even though Jenny takes a sort of a copyright perspective on what's going on here, I think what's more important probably is the trademark aspect of this. I guess you could say that somewhere, someone who's going to see a model that's titled cup holder for Honda is going to say in their head, aha, this must be officially sanctioned Honda intellectual property. This is a part that Honda has actually signed off on. It's guaranteed to fit my Honda Civic from this model year to this model year. There's a distinction between something that is Honda brand and something that is compatible with a Honda. I don't think a reasonable person could look at the situation and say, someone has put up a model for a replacement louver for a Honda Vent. Does that mean it's made by Honda? No, it's not made by Honda. Obviously, it's being made by my 3D printer right over here. And that's not made. That's not a Honda 3D printer. So I think that Honda just really screwed it up on this one. It's almost as if there was a room someplace with a meeting and one lawyer, corporate lawyer who's probably never been out of the practice of corporate law in his or her life probably went to the other one and said, hey, did you hear about this 3D printing thing? It's all new. And I think there's some bones to be made here. We can mine this for some intellectual property violations. You know, I'm exaggerating a little bit, but I think to some degree that's what it is. People are thinking, well, wait a second, what is this 3D printing thing that they're talking about? And looking into it a little further, and it's Honda. Oh no, we can't have that. In issuing these takedown notices. I think the title is exactly right. Honda has failed to read the global room here.
I certainly agree with that, but I'll be willing to play devil's lawyer here. And if I were Honda and I saw people uploading models that said Honda Civic cup holder, I would say that this could create brand confusion in people's minds, and that they might think that this was an official Honda Civic cup holder attachment, right? And what you said when you first did this was cup holder for Honda Civic. And I think if that were the title of, the 3D model, Honda wouldn't have a leg to stand on. But I think as soon as you put Honda something, that is close enough to saying it's a Honda something that their lawyers would, start rubbing their little hands together. And I totally do see that here, actually. And so I'm a little bit worried. I went looking and couldn't find out whether the takedown was all for 3D designs that had names like the one case or the other, whether they were only targeting the ones that were like Honda cup holder, or whether they were also targeting the ones that were like cup holder for Honda Civic. In my mind anyway, that's a huge distinction. I don't know if Prusa had to do this, but again, on the other hand, I would surely hate to have my company sued by Honda's lawyers. So that maybe sounds like reasonable reaction. I guess they could have asked Honda whether they just wanted them to change the names or whether they wanted them to take the models down, because Honda can't possibly have a claim against the 3D models that people generated. You should be able to make your own 3D printed car parts or whatever else designs. I mean, there's nothing preventing you from doing that, even if it fits someone else's car or whatever. But then if you call it theirs, if you say, you know, this is an official, if someone decides to just start calling their blog Hackaday, I'm going to call my lawyer. I'm not going to lie to you, right? If they say, here's the blog where I like to read Hackaday, I'm going to say, awesome, I like to read Hackaday too. But what Honda didn't do here, and what I think they could have done, is realize that they have an enthusiast community that's interested in printing parts to work with their cars and modding their cars, or, you know, that's where Jenny's "this misreads the room" is exactly right. They have taken, you know, their most enthusiastic car owners, the people who are wanting to share their tweaks and personalizations to their car, and like just shut down on them. And I think instead, if they'd done something, you know, maybe more nuanced, like saying to Prusa, look, you have to convey to these people that they have to call it cup holder for Honda Civic instead of Honda Civic cup holder, everything's cool.
I think as this moves along, cooler heads will prevail, sort of thing. One hopes, anyways. And they can embrace the community, or Honda can embrace the community, like you said, a little bit more. I think it's Ford that does that, right? I mean, they even like give you interfaces and stuff like that for how to build things for certain models of their cars. Yeah, there's companies that do it right, and there's companies that just don't do it wrong, and there's companies that don't do it at all. And I don't know which one's worse, you know, not doing anything to engage a community of enthusiasts, or pestering them.
Well, here's my conspiracy theory, and I think I'm the only person who thinks this. And if it's a naive, optimistic conspiracy theory, so be it. That's just the way I roll. Here it goes. If you need to enforce a trademark, you need to enforce it because you are in the same business as the people infringing on your trademark. So imagine that Honda all of a sudden is seeing people 3D printing parts that say Honda something something. Honda is about to enter the 3D printing market, and they're about to enter the market to sell STLs or step files of genuine Honda approved add-ons to their various cars. And as soon as they did that, they're like, hey, wait, there's people in this space using our name. We have to warn them, very friendly, warn them with a little bit of a lawyer notice that they're infringing on our trademark because we want to get into this space ourselves. I don't think it's true. I think I'm being naive and hopeful. But my naive and hopeful hope is that what Honda's going to do here is start putting out official STLs for add-ons for its cars.
And charging through the nose.
And making you pay for it, maybe. Yeah, who knows? They might be trying to sell them, or they might be giving them away free. Either way, if you wanted to do this as a, you know, even as a positive PR stunt, you would have to clear the room of counterfeit Honda parts too.
I like the way your mind works.
That about wraps it up for this week's Hackaday podcast. Thanks for listening. If you have anything you'd like to say to us, write us an email, editor@hackaday.com. You'll find all the show notes at hackaday.com/podcast, and our tips line, tips@hackaday.com. Until next week,
keep on hacking. I don't know why I said it like that. Keep on hacking. Keep on hacking. And I'm Dan Maloney. I'm screwing up already.
Crazy. Crazy.
Done.
Wago. Es heißt Wago.